Now, a little background on our last section of Module 5. This was actually included in the old Module 2, but they wanted to give you a little more background before they laid this on you, in a sense. So these will be word problems. We'll also look over the Pythagorean Theorem, and then fitting polynomial functions to data as we go down. But a little background on example 1 here. Here, two fellas are neighbors, and their house numbers are consecutive even numbers, and the product is this. So that means you're going to take these consecutive even numbers, multiply them, and it will equal this, and they want you to use that quadratic equation that results to solve it. Well, first of all, when we're thinking of integers that are consecutive, we would think, let's say, 5, 6, 7. Well, 5 would be x. 6 would be x plus 1. 7 would be x plus 2. Now here we're thinking consecutive even integers, as are described in the problem. Well, it'd be like 6 and 8, so the 6 would be the x, and the next consecutive integer, or even consecutive integer, would be x plus 2. And that would apply also if you had, let's say, a 7 and a 9. These would be consecutive odd integers if the first number was x, and even though it's odd, we're just adding 2 to an odd to get our next integer. So a background of how to do problems with either consecutive integers, consecutive even, or odd. And here I'd say, well, those are the same thing. Depends what number you're starting off with. Here you're defining your first number as even. Here you're defining your first number as odd. And just adding 2 gets to the next one. So what would be your equation here? Well, it would be x for the first even number, and it's the product is what they're saying, x plus 2. And we're saying that equals 360. So you get x squared plus 2x, transpose this, negative 360 equals 0. So you could use the quadratic formula. A is 1, B is 2, and C is a negative this, or you could try to factor them. And interestingly, all of these are factorable because this is from Chapter 2 stuff. So we have an x and an x. And now we're looking for two numbers that have a difference of 2. So that when you multiply them, so one will be positive and one will be negative. When you multiply them, they end up being 360. But when you subtract them, they're going to be a 2. So you might say, how would I ever figure that out? Well, the strategy might be this. Do a little prime factor tree where 2 will go into there, 180. 2 will go into there, 90. 2 will go into there, 45. Now there's no more 2's left, so we're going to start with the 3's. 3 goes into there, 15. 3 goes into there 5 times. So along this edge are all the prime factors. Now you want to see what combination of these factors will give you two numbers that have a difference of 2. So as we start here, we go let's see here. You try them out. So let me get back here, and after I think about it a little bit too. Well, yes, if you look at this, we'll take two 2's here. This will be a 4. And we take this 5 here. This is 20. And this is 2 times 9 is 18. So let's try, we need a positive. Going to have a positive 20 and a negative 18. So again, I had to fiddle around. It's sort of like a little challenge here to figure out what it is. And 20 times 18 is 360. And the difference between 20 and 18 is a 2. So when I FOIL it, it works. But what are your answers? Well, here, x will equal the negative 20. And here, x will equal a positive 18. Now, we don't have house numbers that are negative 20. So we reject this answer. And this is our first house number. So it would be 18 and a 20. Consecutive even integers. And the way we found it was knowing the theory of finding consecutive integers. They say the product of them, which we did here, was this, and then we factored. Now you could have also used the quadratic formula, but factoring is another way to do it. All right, let's go on to example 2. Now in example B, we talk of a rose garden shaped like a triangle, and we know the area. Now the formula for area is 1/2 the base times the height equals the area. So far we have 130 for the area. Now it says its base, which is this down here, is 7 feet longer than its height. So the height of a triangle is just its altitude. So this would be like, let's call that h as for height. And then this is its base, which is going to be the height plus 7 feet. So there's our base and there's our height. So we're going to put in there 1/2 and then h times h plus 7. So again, I've read this a couple of times. I knew I needed a triangle, and this helps me to visualize what I need, and you need to know this formula. So what's the first thing I would do? Well, I'd get rid of my 1/2 by multiplying both sides, because this is one term, by 2, and this by 2. So here the 2's just cancel out. I can save a little room by doing that. And this is going to be 260, so I'll just change this to 260 here. Now, I'm going to get h squared plus 7h minus 260, as I transpose that, equals 0. So we get a quadratic equation, and this we're going to look to factor as well. Now again, you're looking for factors of 260. Well, how do we do that? Well, I'd make one of these little things and see what we get. So here are the prime factorizations, and this one works out very easy. 2 times 2 is 4, times 5 is 20. 20 times 13 is 260. And the difference of a 20 and a 13 are 7. So it's going to be H 20 times 13. So we need a positive for the 20 and a negative for the 13. So H will equal 13, or H equals a negative 20. Well, again, you don't have a length that's negative, so we reject this. So our height is 13, and 13 plus 7 is 20. And if we multiply that together, we get 260. These are our answers. And again, you're looking for a model. If you get a problem like this in your log, as you do practice and quiz-mes, you have it written, including a diagram, and in your class booklet here as well. Okay, Kim throws the ball off a rooftop, and we're wondering how much time in seconds where that ball will be 12 feet from the ground. Now, if we wanted to see how long it would take to reach the ground, that would be 0, but we want it to be at 12 feet before it reaches the ground. So this is the formula: negative 16x squared plus 8x plus 60 will equal 12 feet. Now, if we wanted to see how much time to hit the ground, we would put a 0 there. We want it to see where it's going to be 12 feet above the ground, and that's the formula. So what we do is we take the 12, integrate it to this side, and you got to copy. Now, generally we like to have our first term positive, and I see I can factor out of each one of these an 8. So I'm going to divide everything by a negative 8. And this makes this then x squared minus x, 2x squared there. And this is going to be a negative 6 equals 0. Okay, now again we said all of these are factorable, so instead of having really big numbers now, our numbers are much better. So this is going to be a 2x and an x, and this is going to be a 3 and a 2. So here we have a 4, here we have a 3, and the difference is 1. So we need this to be a negative, so this is going to be a negative, and this will be a positive. Now recall, solving this, we equal each of these factors to 0. We've been taking a shortcut, where here x is going to equal a negative 3 halves as we solve for this, and here x is going to equal 2. And again, we're thinking time. So for the ball to drop from the rooftop when she throws it to reach 12 feet from the ground, it's going to take 2 seconds. Again, we reject this negative value. It doesn't take negative time. So once again, you're reading the example. A picture might help. You put your material that you know into the formula they're giving you, put it in standard form, try to keep your first term positive. Now you could have used the quadratic equation, where a would be 2, b would be a -1, and c would be a -6. Okay, let's go on. Okay, I've read this now a couple of times, and we have a sidewalk going around a rectangular park. So, I didn't draw it to scale, but so you can see what we've done here. The red rectangle is the park, and then this outer area is an equidistant sidewalk. Now the park is 15 feet by 18 feet. Now, do we know the measure of the sidewalk? And the answer is no, we don't know the sidewalk, but we know it's the same distance all around. So here it's going to be x, and this is an x, this is another x, and this is another x. So it says the total area of the park plus the sidewalk is this. How wide is the sidewalk? Well, area is length times width. So what we have to determine here is what is the measure of the outside width here and the outside length. Well, we know this part is 15, so this is going to be 15. Now, how many x's do we have? Plus 2. So this is the width. It's this 15 plus this x plus this x. So now what will the length be? Well, it'd be similar. It's going to be 18 plus an x there and an x there, 2x. So this is my outside width, this is my outside length, and it equals this area. So the formula is going to be 15 plus 2x times 18 plus 2x, and that'll equal the area of 598. So the protocol to solve it, we're going to have to FOIL this. Once we do, we get a trinomial. We move this and integrate it by transposition into our trinomial, equal it to 0, and then we factor. So there's lots of little calculation. So we'll do this in parts. This is 270. My outers would be a 30x, 36x, add up to 66x, and my last 4x squared. Now I'm going to integrate this side into this side and put this in standard form. Now I'll move this over, this stays in the middle. I'll subtract this from that, and I get this. Now, if it's smaller numbers, it's a little easier to factor. So I'm going to divide everything by 2, because I can't take a 4 out of everything. Now, it took me time to factor this. And again, these are rather difficult. You can do that technique with the 164, but you had to integrate this as well. But these are the factors. So here, x will equal a negative 41 halves. And of course, we're going to reject that one. And here we have x equals 4. And that is the one we use. So our width of the sidewalk around the property is going to be 4 feet. And this was a difficult one, but again, if you had something like this on your final, and you had all of this, and you got here and you just had trouble factoring it, I'm going to give you 75%. You've made a picture, you've done this, I will give you partial credit. All right, let's go on. Now, here we have a Pythagorean Theorem problem, and you might recall that we said if this were side A and this was side B, and the side opposite the right angle, side C, which is often called the hypotenuse, that if we squared side A and added to the square of side B, that would equal the square of side C. This is the Pythagorean Theorem. Now, what we have to do is put information from our problem into this diagram and then develop a theory where we're going to solve for something here. Okay, let's use black just to change colors here. It says one leg of the right triangle is 3 centimeters longer than trice, which is 3 times the length of the other leg. So we're going to call this leg here, the short leg, we'll call that x. Now this leg is going to be 3 times what x is. That's this part here. Trice. Haven't seen that word around for a while. Trice the length of the other leg plus 3. So this is the length of the long leg. X is the length of the short leg. Now they are telling you what the length of the hypotenuse is. This is 25. So we want to solve for x, in a sense. So our equation is this. A leg, which is x, that would be squared, plus the b leg, that needs to be squared, I get a kick out of that word trice. Haven't seen that around lately. Anyway, is equal to 25 squared. All right, we can start working this here. This is just plain x squared. Now here we're going to square that binomial, square the first term, 9x squared. Multiply these two together, that gives you 9x, double it, 18x, and square this term, this is plus 9, equals 25 squared, which is 625. All right, now we have to put this in standard form. So I combine these two, get 10x squared. This doesn't change. I subtract now 625 from the 9, and I get a negative 616. Now again, these are big numbers, but the only thing I can take out of every one is a 2. Again, if you make the numbers a little smaller, they're a little easier to work with. So this is 5x squared plus 9x minus 308 8 equals 0. Now again, I played around with this, and you may probably have to use the Pythagorean Theorem, but this actually factors, as we said all of these do. Now here you know it's going to be a 5x, but now you'd have to look for factors of this 308, and it comes out actually as 44 times 7. Now what will our signs be? Well, our middle sign is a positive, so this one is going to be a negative, and this will be a positive, because this is 35, 44, the difference is 9. Now again, when you solve this, you get x equals a negative 44/5, and here you get x is a positive 7. So this is rejected because we don't have negative lengths of anything. So our x value for the short leg is going to be 7. This is going to be 3 times 7 is 21, plus 3 is 24, and 25. So they're asking how long are the two legs? Well, the short leg is 7, the long leg is 24. And how did we do it? Well, we used the Pythagorean Theorem, read the problem carefully, made a picture, put values for our legs, and then substituted into the Pythagorean Theorem, and there are all the steps. And again, I wouldn't have been able to factor that. I lucked out. And I would use the quadratic formula, where A is 5, B is 9, and C is this. And it does come out even. So again, if you knew these were the answers, then you knew that this is factorable, because there's no radical numbers here. Okay, this will wrap it up. Again, good luck. You'll be ready for your Chapter 5 test if you are up to date and have your mastery points. We just have one more module to do, dealing with logarithms and all those good things, and we'll help you through that as we did with these.